Good afternoon, ladies and gentlemen, and thanks for your presence today at Buyin, a purchasing subsidiary of Orange Group. I am honored to conduct this presentation at your premises with a precise subject that I'm particularly fond of, forecasting. You work within a world leader telecom operator and may wonder how a budget is established, above all when you work in purchasing. Well, there is no magic in that. At the time of AI, how do things work? And how do we foresee the future? Answering this question is the aim of today's session. Let me introduce myself. I am Matthew Pomelet, a French and American citizen and Sciences Po Paris alumni. My career was mainly conducted in industry as export sales director within the airport and aircraft industry. I also have established an M&A boutique, Sorbonne Finance. For several years now, I teach economics in French business schools, having developed a specialty in econometrics and forecasting. Figures is my job. Future represent an anxiety. Not knowing what tomorrow will be has generated a whole set of irrational attitudes, notably the belief in astrology. A French astrologist of the early 16th century, Nostradamus, wrote endless, incomprehensible texts supposedly describing the future. Interpreters understood, for example, that Nostradamus stated that 1939 was not an appropriate year for a war. Economy is by excellence the activity that requires forecasting the most. Not surprisingly, this science abounds in statements that miss the point completely, such as Irving Fisher, a major U.S. economist, who said in 1929, 2 days prior to the New York Stock Exchange collapse, that stock prices have reached what looks like a permanently high plateau. Other economists are wiser, though, such as Kellogg Albrand, who said, "I've seen the future, and it looks very much like today, only longer." This presentation will be split as follows: forecasting and essential science. 1. What are the models? 2. What about Orange Group? 3. Let us try AI. 4. CSR, AI, and forecasting. 5. In conclusion, you can never see what tomorrow brings, but cannot go without it. Economy, in general, cannot go without forecasting. Corporations make forecasts so as to conduct investments. States make forecasts so as to establish a budget. Households make forecasts for their budget and future situation. Let us now focus on concrete examples of successes and failures. The Scottish widow is a good example of how forecasts can work successfully with reasonable calculation. In 1744, Alexander Webster and Robert Wallace, two Scottish ministers, while calculating the average number of ministers dying every year and how many left a widow behind, estimated that a £2 a year contribution by each living minister in Scotland could supply all remaining widows a £10 annual revenue in return. The estimation revealed to be true. The failure of Kodak is also a counterexample of missed forecasts. The incredible growth of digital photography in the early 1990s did not catch the attention of the company, even though the R&D department had warned them. The board refused to admit that families would give up their photo albums. And indeed, families did give up their albums, turned digital, and gave up buying Kodak cameras as well. And Kodak definitely filed for bankruptcy in 2012. In another field, demography, the P-bomb is a strange case to observe. This book was published in 1966 and is the work of a prominent Princeton statistician of the time, P. Ehrlich. His forecast was that around 1980, the world population would reach 15 billion inhabitants, resulting into massive starvations, wars, and the rule of brutal dictatorship. What came after 1980 was exactly the opposite of Mr. Ehrlich's forecast. The population growth began to decline, famine gradually disappeared, the standard of living accelerated its growth, and democracy spread. Statistics can fail just as well. When it comes to economy, a model is a simplified description of reality designed to yield hypotheses about economic behavior that can be tested. So let's try to make forecasts for urban groups using statistic-based models. Statistics is not the scientific form of lying, as many say. This session is not a math class, but simply shows how we can apply statistic models to make reliable forecasts for Orange Group. We will see the making of an equation, the observation of time series, and modeling with several variables. We will make an equation, which is model number 1 in economy, using the growth in sales revenue of LVMH Group. It is obvious that within the decade between 2011 and 2021, the company has tripled its sales revenue. This mainly due to external acquisition. The method commonly used by statisticians to adjust a series of figures, such as here the sales revenue of LVMH, is named the ordinary least square, or OLS. In other words, using statistical estimators such as averages, variance, and covariance permits to establish a line that has the equation y equals ax plus b. Of course, no activity can be reduced to a line, but as the graphic shows, the equation of LVMH, y equals 3.63x plus constant 19.42, permits to predict not the real revenue, but its trend, and roughly where it will be within the coming year's month. Orange Group sales revenue shows an almost quintessential situation of time series, meaning with ups and downs following seasons. In the case of time series, you need to calculate the OLC equation, as per the former slide, and adjust the equation with seasonal coefficients, things we will see in the next chapter. So far, we have seen models with two variables, an observed result and time values, month, weeks. What happens when several underlying data explain a result? Meaning, can I make forecasts with different parameters, such as here, this company selling second-hand cars? Observations show that the final price seems to depend both on age and mileage. The equation will now include two variables and will be of the type price equals beta 0 plus beta 1 car age plus beta 2 kilometers. Beta 2 is a constant, beta 1 is the coefficient for car age, and beta 1 for kilometers. Firstly, one can see that regression lines graphically assess the model with a strong correlation between both variables and the price. What is called a statistical test, in that case a Pearson test, will assess also the model with a strong correlation of 0.79, close to 1, meaning to 100%. The conclusion is that we can now set up an equation, price equals 32.46 minus coefficient of age 1.54 minus coefficient of kilometers 0.15. The equation will always have a leftover mentioned here as epsilon. This result is easily obtained by using Excel. Let's now apply those models to Orange Group using figures of various origins, such as the sales revenue, the possession rate of smartphones in France, or the world market of telecom. Let us look at the quarterly sales revenue of Orange. Using the method of the ordinary least square, it is possible to trace an equation such as y equal ax plus b. The result is 0.057x plus 10.54, obtained by using Excel. Let us now calculate a seasonal coefficient, dividing this time series in quarters. Average of averages permit to establish, on the last column of this worksheet, a seasonal coefficient, which is an estimate of how data vary seasonally. So weighing the coefficient with the figures obtained in the equation will result into another time series. On this graphic stands the effective sales in gray and in orange, where the forecast would have been using the time series models. The result is amazingly close. We will now build up a model with several variables to obtain the year sales revenue of orange. We have two parameters that may affect these year sales revenue: the world market of telecom in billion of US dollars, and the possession rate of smartphones in France, Orange Group being French. Here is a worksheet with the equipment rate of smartphones in France, world telecom market in billion US dollars, and effective sales revenue of Orange Group, per year, of course. Thank you, Mr. Excel. We will assess the model and build up an equation. After having used Excel, one can easily find both an equation and a Pearson test with a result of 0.95, meaning correlation is very high. The equation comprises x1 as the possession rate of smartphones in France, x2 the world market of telecom in billion US dollars, and the sales revenue of Orange equals them minus 39.75, the constant, plus 197.75 x1 minus 0.053 x3. This looks like a mess of strange figures, but after testing the correlation, let us test the equation. Applying the equation shows there is a difference between the effective revenue in column 3 and the estimated one in column 4, but never immense, and that will permit to establish forecasts for budgets, for instance. Knowing the changes in the possession rate of smartphones in France and the volume of the world telecom market could possibly permit to make forecasts for the year to come. How will our forecast work with AI using ChatGPT, for instance? ChatGPT announces a drop in Orange sales revenue for 2025 and then a growth again in 2026, the two of them turning around 40 billion euros. Well, see what tomorrow brings. Getting now to CSR, can we estimate the carbon footprint of Orange Group in the future? Orange Group considers that 1 million euros of sales revenue generates 245 tons of CO2. So transforming the sales revenue into CO2 is very easy. If you take 2024 in this worksheet, you will see that 43 billion euros in revenues corresponds to 10.61 million tons of CO2 emission. You wish to know the future of CO2 emission from Orange Groups? Well, then use the same forecasting models as for the sales revenues. Statistical models are always around, so you will always be somewhere close to the truth when using them. What cannot be forecasted is the evil coming from nowhere, as in the ballet of Tchaikovsky's Swan's Lake, when a black swan, symbolizing death, unexpectedly steps out of the dark. COVID-19 stepped out of the dark, the war in Ukraine as well, but whatever happens, avoid the fortune tellers. The only thing the line of your hands will be telling you is whether you wash them or not. Thank you very much for your attention.